So I may look downwards only because I have my notes on what I'm actually saying on my phone at the same time so that I'm not completely losing my point. So yeah, animations in React Native. As Jen mentioned, I work at Healthie, gethealthie.com. We're pretty awesome, and we do practice telehealth software. Basically, we help out psychologists or therapists and other doctors and stuff to talk to their patients online and do administrative stuff. Yeah, and they're based out of New York, so they're an American company, but they're remote, and we are hiring, I believe. So feel free to ping me afterwards. So now with my work at Healthie, recently, a lot of my work has just been in React, not so much React Native, but I actually got introduced to React Native from working in React, right? So in other places I've worked where they're like, well, you do React, it's kind of the same. You should be able to just hop on in, right? So syntax wise, it looks similar. So that's how I got into it. And I think a lot of people start in that same journey where they start out with React and then get into mobile development with React Native. And it's all the same, right? Except when you start adding animations. This is where the difference between React Native and React really shines and the pain points really come in. React Native has literally its own language for movement. There is no CSS, there is no DOM manipulation in that sense, right? We can't just say, find this element in the DOM and redo this thing. None of that happens. It's like a whole new language. So when you're hit with it, it's super painful, because you're now learning the new language and trying to figure out how to move or create your loader or whatnot, right? And just as you're trying to master that, you get hit with the performance issues. At least this was the stage for me, where everything was really janky, everything was super slow. And that's where this concept I got introduced to was declarative versus imperative animations. Declarative, I'm just going to explain what that wording actually means. Declarative declares the logic of a computation without actually describing its control, how it executes, right? Versus imperative specifies exactly how that function should be executed. So as an example, that is sort of declarative would be, you're asking your roommate to clean up, but you don't really care how they clean up, just that they do the cleanup, right? They pick up their shit after themselves. That's it. Versus imperative, you're the crazy roommate telling your roommate, no, you have to use this cleaner in this exact order and use this brush in order to clean up. You're explaining exactly how they have to clean up and they have to follow that procedure. Now, this is where the performance part for the JavaScript side comes in, right? For us, at least in React Native, declarative makes animations a lot more smoother because it's more performant, versus imperative, us telling how each step needs to be executed, takes up a lot more space on the JS thread and it's a lot more painful. So on that note, if anyone's got questions as I'm going through these concepts, feel free to just pop in. So if somebody can just chime in and just let me know, I'm happy to answer as well. Yeah, so we get into this whole nature of declarative versus imperative, figuring out, whether the native options of React Native animations is supporting declarative or imperative. And then you get hit with all the different libraries out there that also do animations in React Native, right? And they all have their pros and cons. At least in this talk, I'm going to talk about really deep dive into 2 main libraries and a third one that's also supported, and then talking to the built-in options of animated API as well. Now, animated API originally was a separate library that the React Native team then adopted into the root React Native build, right? So animated API library still exists and still does its own things. And some of its functionalities are supported directly through React Native. So you don't need to import an animated API as a separate library. You can just kind of use it through React Native. Layout animations are slightly different, whereas animated API would let you like animate specific, elements, like make this image move from point A to point B. Layout animations focus like on fading in and fading out, transitions like between screens. If you're navigating to a new screen, I wanted to like slide in or something like that. So that's where the native APIs kind of change a little bit. And at this point in my journey of figuring out React Native animations, I figured out I know nothing. I've got to like really start from the scratch. And I'm sure a lot of you guys are also feeling that when you're trying to like understand what it's doing. But trust me, it is normal not to know what the hell you're doing right now. So let's actually like talk about what actually happens when you start animating in React Native. Like you're using the built-in React Native animated concepts. Like what does it actually do? So the animated API built in, this is what it actually looks like. You have a UI thread, a JS thread, and a native thread. And these three things have to talk to each other in order to get something animated, right? So for example, we want to move box from point A to point B, like from point 0 to point 100. So moving it like from left to right or whatever, like translation 0 to 100. The UI thread kicks it off, right? As soon as the component mounts, it's like, hey, we have this animation. This is what it needs to do. Like we send it to the JS thread. The JS thread, this is where a lot of the work happens. This is literally where the JS side figures out, okay, we need to figure out animation per frame. And in React Native, each frame is 16 milliseconds. So every 16 milliseconds, the whole process for the JS thread restarts, like it re-renders, right? So it figures out the box is at 0.0 right now. It eventually needs to get to 0.100. And this is the timing for it. And this is the transition for it or whatever, the delay or whatever else you may add to it, right? Then it looks through from 0.0 to 100 what the next intermediate values are, right? So we have 10, 20, 30, like all the way to 100. So it figures out what it needs for the next 16 milliseconds and then passes it to the view component. The view component being like the native like view component, right? And it then figures out like what props does the view component need, like what logic does the view component need to know in order to like understand where the box is and where the box needs to be, right? And then it packs it all up and sends it to the native bridge. This bridge part is what literally translate the JavaScript into iOS or Android, the native thread, like for the native thread to understand, right? So this whole process happens every 16 milliseconds where it figures out, okay, box is now at 0.10. The next value for the next 16 milliseconds are like, 20, 25, whatever. This is where like the next range is, redo it. And then 16 milliseconds later, box is moved to 25. Let's do this next few steps and so forth, right? Whew, that's a lot of work. And then at the end of it all, the native thread, basically, every time the JavaScript thread says, this is the first 16 milliseconds, the native thread goes, hey, UI, update. So you can actually see in the first 16 milliseconds, box goes from 0 to 10 or 0 to 20 or whatever, and then the progression towards 100. So all the native thread is doing is getting the values from JS thread and shooting it back up to the UI thread. There's like no thought. What this actually means for us is performance issues. A busy JS thread means frame drops. That literally means those janky animations where as you're like doing it, it kind of stops. There's like a jitter, and then suddenly the box is like all the way at like 70 or something, and you're like, hey, why did it just move that way, right? That's where the performance issues and the user UI problems come in. Especially if your JS is also now having to fetch data, mutate the data, and like send it back and all that fun stuff. Ooh, that's painful. This is where React Native team was like, you're right, we've got a problem. Let's try to fix it and they introduced the concept of use native driver. So it's a hook, or like that's a prop that you can add in that helps to make your performance better by moving all of the work that the JS thread was doing into the native thread. So all of that stuff for the 16 millisecond stuff is now just being done by native thread. The only thing the JS thread does is on mat, like when the animation start, it gets all the steps. It gets everything you'll need from 0 to 100, creates this like graph, like animated node stuff for the native thread, and just sends it down to the native thread once. And now the native thread is directly just talking to the UI thread, leaving the JS thread part, like this bit of the JavaScript brain, available to do whatever it needs to do as it needs to do. I'm just going to pause here, and I'm not looking at the chats for any questions, but if there is any, just somebody type in, okay?
Oh, I had a question actually.
Sure.
You mentioned it updates every 16 milliseconds. Does it still update even if the UI hasn't changed, or?
If there's an animation that needs to happen, yeah. So like, for example, a loading spinner, right? Mm-hmm. And it's trying to fetch data while it's spinning. Like if the spinner is visibly spinning and there's like an actual like UI difference in that spinner, guess what's happening every 16 milliseconds, right? So this is happening in the behind the scenes, basically. Does that make sense?
Yeah.
So now this whole process here, like in the middle here, animated API producing the graph, there's like, how does it know what are the values from between 0 and 100, right? So like we've told the box to move from 0 to 100, we're using native driver, awesome, performant, but now it's sort of have to guess the middle grounds. What is the middle ground here? This is where the concept of interpolation comes in. It's basically a type of estimation to find those values in the middle. I've actually put a link to a YouTube channel here called like Evening Kid on YouTube. He's really good at explaining this. And in fact, like out of all the tutorials I looked through trying to understand what the concept actually meant, his explanation was really great. And I'm like copied some of that concept here as well. So like it literally, interpolation is figuring out this function to figure out, like map these values, and doing that once so that so that your JS thread is open to go doing other stuff. Now this comes in really handy, especially if you're trying to do two things at the same time. So now we're not only moving the box from 0 to 100, as the box is moving, you want opacity to change from 0 to 1. How does, JavaScript and the native thread and all these fun stuff know what the middle value for opacity is? Because opacity is 0 to 1, translation is 0 to 100. It's like two different ranges, right? The interpolation part of like animated like native API does the magic there, where it'll figure out the middle value is 0.5. So like in the setup, it will figure out for you that when your box is at 50, opacity should be at 0.5. Does all of that make sense? Hoping yes. So I have actually a little snippet of code, because me talking about this may not be as visibly helpful as like just seeing a sample of code, right? So here I have animated.value. This is coming from React Native's built-in animated API. I'm defining my initial translation value as like animated.value 0. And here I'm saying it's a loop animation. This timing part is how animated API understands time, like every 300 milliseconds or every whatever time frame you give it. Like that's how it's keeping time basically for each loop. And then the translation, 2 values. So you're saying it's a translation property. It's going to value 100, and the whole animation should take 3000 milliseconds. And again, use native drive true. That's what is basically compressing it all for my JS thread, making it performant. And this starts it off. And here, this animated.image is how I'm like saying this image, native image component is what I'm animating. This is how I'm defining that this is the piece This is the component to animate. And here you can see how I'm passing it into the style where the transform is happening for the translate X translation, and same thing with opacity. You can see the interpolation part where I'm saying translation dot interpolate. That's how I'm defining that, hey, when translation starts at like 0, like make sure they map at the same time, right? I could just say, hey, also like transform opacity separately without the interpolate, but that does mean like I have no guarantee that when transformation, like the transformation is at 50, like when the box is at 50, that the opacity would also be at 0.5, like that mid-range, right? This is forcing that to be tied together timing wise. The input range here is what I'm telling it to say, hey, the translation is 0, 100, and my output range is for the opacity values. They need to be mapped to 0 to 1. All of that makes sense? Hopefully, yes. So, question? I heard somebody's mic. Maybe not. Okay. So all easy peasy there. And now we go into the next concepts of extrapolation and clamp. So like, what if you want to change opacity when the translation is at 25, when the box is at 25, and end it before the box finishes moving, right? When the box is at 75. That's where the concept of extrapolation and clamp comes into play. Extrapolation is literally the figuring out of the numbers, of the intermediate values, and clamping is setting like a solid range. It's literally just saying these are the boundaries for that change. So this is sort of what it looks like in that math range. Sort of, you're saying here, translation is 0 to 100, but my input range now only needs to be 25 to 75. That means when translation is at 25, start my output range to be 0. And when it's at 75, start it to be like, finish it off at being 1, right? And then there's this bit here. This is how I'm like, this is the extrapolation part. And then this bit here where it's figuring out, oh, well, when translation is anywhere between 0 and 25, what is the value? That it's extrapolating as, oh, that should just be 0. Same thing here, it's extrapolating it as just being 1 because you've put these clamps here, basically. So this changes our code basically to look like this, where I'm just saying extrapolate clamp, and you can see my input range has changed. So the code in itself, very similar to the last bit, same concept. Only big difference is I'm stating there's a clamp of 25 and 75, and that it needs to extrapolate by itself. Like that in itself, with like our built-in React Native's animated API, does the trick, right? So we're done, all good. We've got animations. We don't need to know anything more, right? Awesome. Sadly, there are limitations to use native thread and animated API in itself. Not everything you can do with animated is actually still like currently supported by the native built-in options. The main limitation is that you can only animate non-layout properties, things like transform and opacity. So anything that you want to do with like flexbox or background colors won't work. Another one is animated.event. The built-in one will only work with direct events and not bubbling events. So a big example of that would be, it would work with like a scroll view. If you're scrolling through and you like flick your finger and it like scroll animation creation, it would work. But if you're doing like a pan responder where you're pinching and zooming in, it wouldn't work. So again, you're back to some of the glitchy frame drops or not even being able to do that kind of animation with the built-in options, right? So this is where the libraries come into play. So I'm going to cover React Spring and Modi here in this talk, really. React Spring is like physics-based, and Modi is sort of the new kid on the block with animations. I personally really like it only because it brings in, it's like built on top of Reanimated. Now, Reanimated is one of the most popular libraries out there for doing animations in React Native. It's super awesome. It does a lot of stuff, but because it does a lot of stuff, it's super complex to try to like actually use. There's version 1, which works pretty well. And then version 2 brings in a lot more performance updates, and is now supporting hooks and all that fun stuff. And it is trying to bring in the same concepts of like spring-based animations versus timing animations. And I'll define what the differences are in a bit. Also into this, that means it's trying to be like the all-in-one jack of all trades. So it's a really big library. It does a lot of stuff. Modi basically is a layer that sits on top of it and tries to simplify some of its like, root logic. So let's look at React Spring. It's a physics-based animation library. Now, what does that actually mean? It means it tries to mimic the real world. Like it doesn't, we're moving away from the concept of timing defining our library, our animation, to things like what would happen in the natural world actually affecting it. So like things like mass, friction, tension, right? All of that. It's built on, it was originally built on the animated API library and React Motion. Now, the original animated API library was more imperative and thus less performant. React Motion was the concept, was the library that brought in the concepts of the spring-based animation concept, like that natural, flowy, almost realistic feeling animations. And it added, basically React Spring took all of the good stuff of these other libraries and then made it declarative methods. That meant it made it much more performant. So using it is no longer painful. And the best part about this is you can use it in web and mobile. So those, I think you guys may have seen, so those bouncy ball like animations where it actually looks like somebody threw a ball and it bounces properly. Those are like usually physics-based animations. They're like built with React Spring. Even their logo is like an animated little concept, and I can show you that in a bit. Like right here, this is their logo. This is sort of what the React Spring like physics-based animation looks like. This actually looks like a very bouncy ball stuck inside a coil of springs, right? And what I'm using here is like the pan gesture, or like the gesture native stuff in CodePen, just to like recognize that I'm pulling it and it's reacting like it would in the real world. This is a CodePen, like a code sandbox out there. You guys can definitely Google it. Just look for React Spring logo and this will pop up. It's really cool because it like gives you a lot of like detail on how React Spring itself works without like having to like download it and all that fun stuff. So you can play with it right here. So here you can see like this use Spring, that is literally how they're kicking in the hook that is defining what the animation should be. So it's saying on grab, do all this math, this tension, friction, precision, like that is what's defining the natural physics feeling of that. And this is all the math for the gesture, like based on when I'm pulling and grabbing, where is the position of the ball, what it should do, like when the grabbing versus grab motion changes, where should it move and how should it bounce? All of that is like defined here in this like algorithm bits of it. So, but the big cool part for us is like, this is literally the Spring controls the red atom, like this is literally it. So it's really cool. Feel free to go, look through it at your own time. But for our purposes, the same concept of a very simple animation where I'm just rotating an image. I'm not doing anything super crazy. I'm doing it on a loop, and that's all it, like, this is literally it. That's all I need for that animation to happen. Like, I don't need to figure out the timing craziness of it all or any of that. I just use the use Spring hook. This animated bit here is coming from React Spring. And then again, the hook coming from there. I'm stating what the from rotation degree is to rotation degree, that it is a loop, and this image will have a mass of like 0.5 and a tension of 200 and a friction of 100. And further down, I'll actually show you what this actually looks like when we like set up the simulator going, and I can show you a sample of it, but this is the sample of what the code looks like at least. And yeah, and here I can just apply it directly to my animated view, which is this, and it just does its job. I don't have to worry about it too much. So there's that. Now let's jump into Moti before I go show you guys like the live coding samples of this. Moti built on reanimated v2. Now, yes, we get hooks, components that take, you know, the object and like does it. Like the big thing about Moti is like it takes the reanimated hooks, makes it into a component, and you just pass in your props and you're done, right? But the big awesome part about reanimated v2 is this JS context. So now, if you're doing really complex animations, you still need the JavaScript thread to like do some calculations and stuff. Reanimated v2 has figured out a way to like add this extra thing called the JS context. It changes how React Native in itself works, where now you can define that just your animation piece, that snippet of JavaScript works inside the JS context, while the rest of your app continues to work with the UI thread, JS thread, and all that fun stuff. So your JS thread can continue to fetch and mutate and do all of that fun stuff. But you can specifically say, hey, this is a worklet, which means it needs to be inside this JS context. Don't make my JS thread work too hard. Like make this a separate thing. So reanimated v2 is really cool about like improving performance. This means you can have really complex, really awesome looking animations, and it won't throttle your JS thread. You can continue to do your stuff, right? Which is really cool. Moti uses all of these cool concepts of the performance and then also combines other libraries. So like it's got the concepts from React Spring with the physics-based stuff and allows you to like play with that as well. And Framer Motion was another animation library that does a lot of these on mount and on exit, like on unmount transitions. And it does really cool movements. And Moti tries to like also bring that in. And it is mobile first, but also works on other platforms. So the guy who built Moti does a really great talk for the Next.js conference that walks you through how to make Moti work with Next.js, basically. So you can have like server-side React application and still have all these really cool animations and almost like a mobile kind of feel for your application, even in web. So this is what Moti looks like, the code sample for it. So as you can see, I have no hooks, no extra logic here. It's literally, I'm calling this Moti image component from the Moti library, and I'm just passing in props to it, right? So I have the from, where I'm saying, hey, transform this to rotation of 0 degrees. And the animate, I'm saying when, you know, the transformation needs to go to 360 degrees, like from 0 to 360. And here, transition, you can see I have this thing called type, where I specifically define it as being timing. It'll take the option of either timing or spring, right? If I do timing, I get to put in duration saying this is time-based. But if I do spring, instead of duration, I'd have like similar properties that we saw with React Spring, right? We'd have mass, friction, tension, all of those fun stuff doing the job here. And then the looping and all that fun stuff. So at this stage, oh yeah, I also wanted to show you the reanimated v2. Now this snippet of code, disclaimer, I wrote this a while back and I tried to make this work today and it's not working. And I can't figure out why reanimated v2 one is not working as well as it should be. The big thing here is, you can see here, I have use animated style. That's the hook coming from reanimated v2. And then I'm passing in like a rotation value. So like the use shared value, that's how I'm telling it, hey, the original value is 0. Now with the animation bit, the value changes to something else. This with repeat and with timing is again how I'm telling reanimated that this needs to be on a time schedule and it needs to repeat quite a few times. I, for the life of me, could not figure out how to make it loop properly. I tried just about every other hack I could, but there's not a lot of docs explaining the looping part of this very well. In reanimated, when you look through the docs, you'll find something called a clock. That is how this with repeat with timing bit, that's what's controlling it, controlling the clock. And it's painful. Trust me, it's painful trying to get the loop part working. So this is like a shitty hack of like trying to get that same feel that Modi provides very easily with just the loop true or false in reanimated. You can already see it's a little bit more complex in trying to figure that kind of stuff out. And then you again have for the transform of like what the actual value is, and you're just passing it in from animated.view. Again, the other big pain point I hit with reanimated versus like Modi or even React Spring was that if I wanted sequenced animation, so if I had like 3 boxes where I wanted one box to move and the next box to move right after the first box moves or something, reanimated makes it really painful versus Modi was really nice and easy to like set that up. And in fact, we're at the place where I can show you some code and we can like just talk about the same concepts. So I'm hoping you can all see my code editor.
I'm a little blind. Can you make it a tiny bit bigger?
Yeah. So give me 1 second. I'm just gonna try to get my yarn opening bit going. As soon as I get like the terminal running and the simulator going, I'm going to set it up into presentation mode, which should make this code a little bit easier to see. 1 bit. Let's do that. I think it's going to change as soon as I make this into presentation mode, but we'll hit that when we hit that. Okay, let's see. View, appearance, enter presentation mode. Okay. Okay, cool. You can all see my very messy desktop. Please ignore that. Okay, so here I've just got a very simple, basic React Native app with the first one being my built-in animated API, loading of a cookie look. Then we have my React Spring loading. You can see instantly it's very different from the regular circles. It's doing a lot more different feel where it's like got that, you know, quick start and almost like that wobble of a pendulum going backwards. And then our Modi, same concept. It's again got like the wobble bit happening as well. So this animated API code looks like this. So the spin value here, again, is just our initial value of new animated dot value, the duration. And here, this easing part is again coming from React Native. I'm literally stating easing as a function that comes from React, like a option that comes from React Native. And that's how it actually knows to like make this a linear easing animation. And it does the same concepts of interpolation that I was talking about, of 0 to 1, and then the output range for the degrees. This actually plays into the text because I have both the cookie here and the text doing the same thing. But you can see how the text is like loading in, fading out, not as neatly as the cookie is. Like it's a little janky, right? And things get more complex the more pieces I add to this, right? So, and again, like coming back to that whole idea of like staggered. So if I wanted to say like the clamping of like the view piece, like this only happens after this, after the image starts rotating at a certain degree and stuff, this gets a lot more harder to read. So that's our animated. Let me see if I can just, ooh, I can go to, there we go. This is the React Spring. I'm guessing you can all read this pretty fairly well, hopefully. If not, again, chime in. Same concept. I've got my loader text and my actual image, and I'm calling the Spring hook with the rotation from and to, and then finding that. Here you can see the mass, tension, friction, all that fun stuff. And again, the looping part here is super easy. I just say loop true, right? And it does its job. I don't have to worry about it. Awesome, cool. So we already saw what it looks like with the mass of like 100 and a friction of like 100 and tension of 500. The tension part is literally what's causing that cookie to like load really quickly the first time. So when it just, you see how it speeds up first and then does that little wobble. It's literally like if you pull a rubber band and it's snapping back a little bit, same kind of concept. So here, I'm just gonna exit out of the presentation view. I'm gonna change my mask to, I don't know, 800, just to show what the difference is going to be like. And because I can't access the terminal while in presentation view, I'm gonna just switch back real quick. 1 second. Terminal, I just need to reload the app because in React Native, when we make these kind of animation changes, you just need to reload the app for everything to work fairly well. So with the app reloaded, let's go back to React Spring. You can see instantly that it's a lot heavier of a feel. Like it's actually doing a lot more of a pendulum backwards. It's not such a very quick, snappy circle anymore. And that's because now this thing is like, 800 pounds more kind of thing, right? So it's like the feel changes a lot. And again, like if you change friction, it behaves very similar to like what it would feel like in the real world. Super cool, right? And now, while that's doing its job, let's look at Modi. Now with Modi, here you can see I'm just saying Modi has its own image component that React Native also has an image component. So this is just a way for me to say, hey, I'm using Modi image for the verb. So there's a differentiation. Modi view is how I'm saying this is a view component. That whole component is going to have stuff animated inside it, like stuff that's going to be animated. So this way, I'm not actually putting my animation on the text itself. I'm putting the animation on the view component, the text, in regular web world, the div component that the text is sitting in, basically, right? And here again, I just putting from opacity 0.3, animate, doing the transition of timing and all that fun stuff with like delay and all that fun stuff. And here at the bottom is the actual image itself. And I've got a few commented out codes just to show you some other cool stuff. But again, same very basic thing of saying the image component is, shows this image is now going to do this transformation animation of rotation from 0 to 360. That's the animate prop here, and what the transition type is, right? So I can make it a spring, which is what we saw here earlier. That's the spring. Or I can say, timing and put a duration of like, I don't know, 4,000. And it does the same thing. So if I do, again, sorry, as I change code, I just need to exit out of presentation and reload the terminal. Now, if we go to our Modi section, you can see how it's not doing that quick, fun spring bit anymore. It's just doing a regular circle, very similar to what we've normally seen, right? So it's doing the same concepts. But let's just switch this back to our spring. And we can change, instead of doing transformation, we can even do like a translate. Actually, I'm going to just hide that. I'm just basically saying start at -100 and then go to 0. And if you wanted to do like not just go to 0, but you want this thing to bounce, you can like change that from like 0, 100, and then back to 0, like just sending in an array, and it will do all of that very easily. So this is sort of like the staggered animation concept. I'm just trying to show that with this one component rather than all of the different pieces you could add to it. So now if we go to, you can see how it's just like suddenly changes. And now, for example, if you wanted this piece only to like behave like a spring versus everything else, it's like by default, Modi assumes the type is timing, but we can change it where only this one is now like spring by just putting in like different props, and it'll do that job too. So that way, like you have very like granular control where you can say some things are like timing, but I need it to behave like a spring in this one area. Guess what? It does that. And it's super cool. So this is like the part where I thought Modi was outshined a lot of the other libraries, is because it's really hard to do that kind of like interplay between like physics-based animations and time-based animations with like one tool. Reanimated V2 tries to do this, but to this day, I have a hard time trying to figure out what it actually does, like how to like make it work. So you can see like even now, like as it's like doing that second movement, there's like a little bit more of a extra bounce to it, and that changes things. And again, like you can, for each of these shifting, you can add other like special configurations, like the increasing of mass or like increasing of that bounce a lot more, and it'll behave accordingly as you specified it. But yeah, that's everything I have to show you guys, code-wise at least as well. Let's exit out of this.
Does React Spring have preset animations as well?
Yeah, so like not like fully preset, like it does, its API does like tell you all the like built-in things you can use. React Spring, sorry. I've been Googling React Spring logo quite a bit. React Spring docs. So their docs are pretty good about like showing like how to chain animations, and they have like samples of like all the different things that it can do in that sense, but not like even the parallax bits right here. So it's got a few bits where it's like already has components or like built-in stuff you can play with and how to use it. So this one is in a class component. That's the other thing to note is React Spring also does Angular and other frameworks. So sometimes their docs can be a little dated, but it's been around the longest. It's been around much longer than Modi itself. So there's a shit ton of docs on this. But yeah, that's all I have for you guys. You guys got questions? Anything else I can help with or answer?
Yeah, a curious thing. I think you mentioned it. So you said that React Spring is the unique library that works for React and for React Native among all these ones?
So React Spring supports React Native, React, Angular as well. They have like, I think like a cross-platform one, which I'm not sure if it does all the beautiful things as it's supposed to do. It's not as painful or it's not as clean. But yes, it does do that. The web version is fun to play with as well. Modi does allow, it does support web, but last I checked, it supported web like for Next.js specifically, and then web of the React Native web version rather than like pure, like just importing directly into React.
Okay, so of course, I'm assuming it's not a good idea to use multiple animation libraries in one project because of their maintainability, right?
Yeah, like it just comes down to maintainability of like how you want to like handle it, right? So like, for example, right now with Healthie, they're not using React Spring. They're using just the basic animated API. And they have like a bouncy logo for when people onboard, right? They wanted to do the same thing in web, and I was like, can't do that with code. We have to use a GIF. There's just, because it makes no sense to put a whole library, like the Spring library in, because the mobile allows it and the web doesn't. Animated Spring, the built-in one, is starting to do some of these like fun, bouncy ones, but it's very hard. It's very janky. Like it's sort of like using D3 for graphing, you know, like it does a lot, but it's kind of scope. So
my personal opinion regarding choosing the right animation library is to look for the one that is supported by like the highest, like the most important company. If you take the example of Reanimated 2, which apparently you don't like very much, they don't have the mass, MASS. That's true. It is now supported by Shopify, so it's very. To me, it's a good news because I use Reanimated too. But I wonder if there is another company, like big company, that supports one of those libraries that you indicate.
I'm not sure, but I like React Spring, I think, does have somebody else backing it. I am not sure. I just haven't like dug into it as much.
Sure.
But like I said, Reanimated is very popular. There is like, especially V1, there's tons of documentation, and V1 is not as painful to use as V2. It is super nice. There's a lot of YouTube tutorials on it, and I have used Reanimated V1, and it is fun to use. The big shift for me, for like me preferring Modi to some extent, at least for my own like stuff, was the fact that it was a little easier to read. I could use it in Next.js, and the performance give take. Like the V1 version wasn't as performant as V2, and just trying to figure stuff out in V2 was a little bit more painful, which I know they're trying to get better at with their hooks, declarations, and stuff as well. So hopefully, like as they keep making updates, things change.
Perfect. Thank you very much for your presentation and everything.